Okay, so once again, this is Professor Terry Clark. I want to welcome everyone to our Thursday 2 to 4 p.m. Go to training today. This go to training purpose is to help to inform everyone on day 6 of your Alex module. Okay, and so the things that we see on day 6 of the Alex module with the business applications and more of the real world applications for math, we'll be covering that today. Okay, so I will be recording this session, which is what I'm doing now. Uh, Once I finish recording it, I'll send out in an email to everyone who's registered for this go-to training. So if you're not able to stick around for the full go-to training, even for those who did not even show up for the go-to training, if you register for a go-to training, you're automatically on that list. So you automatically get a copy of the session. Okay, my sessions are uploaded to YouTube. Okay, so once you go to that link and you see the session, you know how YouTube works. It'll make everything available that I did in the past month or 2 months or year. Okay, so you have access to all that. So you'll even have access to assignment 1, assignment 2, what we did for day 1, day 2. You'll have access to all of that stuff. Okay, that stuff's good to look at, especially if you got assignments that are late or that you're struggling with. Okay, that's always a good place to go and just look and see, what's out there. Okay. Uh, Let's see. So we're going to go ahead and we'll get started. Okay. Now I'm going to ask questions throughout this process. Okay. So I really like you when I get full participation. Okay. So what that means is that if I ask a question, see if you can come up with the right answer. If you don't come up with the right answer, don't freak out about it. I mean, at the day it is math, and unfortunately, there's only one right answer, and we don't always come up with the right answer. I don't even always come up with the right answer. Okay. But we just learn from what we could have done to come up with the right answer, and then we move forward. Okay, and if you don't know what the answer is, just put a question mark in there saying, hey, listen, I don't know what the answer is for that one. Or I thought maybe I will multiply to come up with the answer. Just kind of honestly participate. Okay, with that being said, we're going to get started with business application. Math is used for everything. Okay, it's used in business. Okay, it's used in education. We use it to determine, what people know and what they don't know. We call those grades. It's used with, medical stuff. You know, we look at, your blood pressure and your sugar levels and your heart rate. So we use it for that. Okay, we also use it for personal things. Okay, like someone asks you how long you've been with your wife. You may say, "Well, I've been my wife 7 or 8 years." Well, that amount of time is going to tell them how stable your relationship is, and how well you do at relationships versus somebody who's been divorced 5 or 6 times. Okay, so we use math, in a lot of different ways. And just because it's not complicated does not mean it's not math. I know a lot of times people equate math with some long, drawn out, complicated formula. But math can be, a fairly simple, process. For instance, I want to see, how well me and my wife were getting along. And so what I may do is say, okay, well, I'm going to take, the next 6 months and see how many times we argue. Okay. And so what I'll do is I'll say, okay, well, over the next 6 months, we argued, say, 3 times. And so I'll divide 6 by 3. And what that's telling me is that we argued twice a month. Okay. And so math is used for almost any and everything. Okay. Now, there was a mathematician by the name of Samuel Gruder who said that the essence of math is not to make simple things complicated. So, we don't have to go and draw out this complicated formula just to understand something simple. Okay. He said instead that math is to take things that are very complicated, things that maybe we might not be able to come up with a definitive answer. For instance, if you ask me, you say, well, what kind of life have you lived? I may say, well, I really don't know. Okay. But, I could take math and quantify that and say, well, in the 40 something years I've been living, how much money have I acquired? In the 40 something years I've been living, how many relationships have I developed? In the 40 something years, I've been living, okay, how many things have I accomplished? In the 47 years living, how much education I got? And so that's what math does. It quantifies those things for us. It doesn't have to be complicated, okay, but it is a tool that we use to make better decisions. Now, I say that because as we start to look at business applications and other applications for math, that becomes the crux of this whole process. Okay, so with that being said, let's look at some textbook examples. Okay, and of course, textbook examples are going to be different than real world applications. Textbook examples, are clean and cut. Okay, and sometimes they have nothing to do with the real world. Okay, real world examples, you may have decimals and numbers that need to be rounded. They're not nice neat numbers like 7 or 8. It may be 7.56321 or something like that. Okay, so here we go. Okay, a concept that we'll work with when we're dealing with business applications, and not just with business applications, but also when we're working with any application, or percents. Okay, one of the things we may want to know is, what capacity of your lungs are you using? Okay, let me make sure you guys can see the screen. Okay, okay. Well, my screen is showing, so I'm not quite sure why you can only see that part, Michelle. First page. Are you showing something else? No, right now I'm just showing the PowerPoint, and it's talking about percents. Okay. Can you see it now? Because I did refresh the screen. I shut it. I pushed it down and then pushed it back up. Yeah, maybe you may want to re-log in and then see what happens. Okay, great. Okay, so this is a percent. Okay, now with percents, percents are used to figure out, how much of something, of the entire thing, are we getting a benefit from. Okay, like in this case, we're going to deal with CDs or royalty payments, but this is not the only place we can use percents. Okay, I was recently in the hospital, and one of the things the doctors wanted to know is what capacity of my lungs was I actually using. Okay, so they had me hooked up on a breathing apparatus, and they would look at it and they would say, okay, you're using 87% of your lung capacity, so we're gonna have to, help you breathe for a while. And then they hooked me up onto a ventilator. And then once my breathing capacity got up to like 97 or 98%, they said, well, you no longer need help from this machine. So they use percentages, they use math, to determine that. Okay, we also use percentages with money. For instance, someone says, well, I'll loan you some money at 16%. And there's that word percent, 16% interest. Then you may say, well, that's like way too much. I know someone who borrowed money for like 7% or 8%. But the point is that percents are used to make decisions about things. Okay, so and a percent is comes from the word per 100. So we see that word percent. One thing we can say is per, and then cents, or we can say cent can also be per century. Okay, that's per 100 or per century. Okay, so when we say 10%, we're saying 10 out of 100. That's what we mean when we say percent. So we're saying 10 out of 100. In other words, if there's 100 things lined up there, we get 10 of them. Okay, if there are 7 things lined up there, if there's 100 things lined up there, we get 7. Now, what percents do for us is it allows us to have a common comparisons for things because all that stuff is out of 100. So you can look at it and you can say, well, when we say 7%, we're getting 7 out of 100 versus somebody else who's getting 12 out of 100. But the person who's getting 12 out of 100 is getting more than the person who's getting 7 out of 100. So that's the benefit of percents. It allows us to take things that are the same and compare them. Okay, with fractions, you can't always do that. Like, say, for instance, like when we say 10%, really what we're saying is 10 out of 100. Okay, and so if it's written as a fraction, and if someone else was getting like 15%, that's going to be 15 out of 100. Okay, well, we can see that 15 out of the 100 is more than 10 out of 100. Versus if we had, say, just like fractions, if we had 7 out of 12, and then we had, say, like 9 out of 15. Okay. Well, just by looking at these at the eye, we couldn't really say who's getting the most. I mean, because, you're getting 9 out of 15, obviously, if there are more slices, each slice is going to be smaller. Okay. Like if you got a candy bar and you cut it up into 15 slices, that candy is going to be a whole lot smaller than if you had a candy bar and you cut it up into 12 slices. Okay. So that is the thought process behind the percent. Okay. And that's why percents are so effective because, we're talking about the same amount and how much of that amount are we getting. Okay. Now, when we look at this, we're going to see that word of. Okay. Anytime you see that word of like that, it always means to multiply. So the word of means to multiply. Okay. And this is important when we're looking at solving word problems. People who are good at solving word problems have the ability to convert English language into math. We know what words mean what math concepts. Okay, and so that's the key. So when I say, well, okay, 15% of 10%, well, I know that means 15% times 10% because the word of means to multiply. Okay, and the word is means equal. Okay, so I'm looking for certain words when I'm looking at a word problem. I'm looking at this and I say, okay, look, there's 10%, and then they said of here, so that I know I'm talking about multiplication, and then they're going to get 15% of that. Okay, so it says, okay, well, what is the agent going to get? 10% times 15%. Well, I automatically, so one of the things I'm going to do is this, and everybody has their own strategies, like for how they solve these types of problems. I'm trying to get rid of the stuff that I'm putting in. Okay, my strategy that I use is called RSTUV. Okay, and I'm going to take that and put that in the chat box below here. So I call it RSTUV. Okay, now RSTUV is what we call an acronym. So it's an acronym. Okay, just like PEMDAS R is an acronym. Okay, now the way acronyms work is that each one of those letters stands for something. So the R stands for read. The S stands for select the unknown, or should I say unknowns. The T stands for translate the English to math. The U stands for use math rules to find the answer. And the V stands for verify the answer. And verify means just double check, verify the answer. Okay, so that's my strategy. Okay, much like if you were playing a sport or if you were cooking, there's a strategy that everybody has whenever they start. Okay, so I'm going to select the unknown. Let me go back in here because I put unknowns. Select unknowns. Okay, so there we go. Okay, so I just put it in the chat area. So I'm going to read. Okay, and when I'm saying I'm reading for comprehension, which is a different just from, speed reading. Because you can read something and fully not understand what you're reading. Okay, so I'm reading for comprehension. You know, I may read this thing 6 or 7 times to get a better understanding of it. If I'm reading this and I'm going to say, okay, as I read this, I'm saying if a musician gets a royalty payment of 10%. So, okay, so I might underline that payment of 10% just to abbreviate it. Then I'm gonna circle that word of because I know that means to multiply. And it says of the CD sales received, but has an agent who gets 15% of what the musician gets. So I'm gonna circulate that 15%. I'm gonna put who gets 15% of what the musician gets. And then at the end, the question wants to know what is the agent's rate. Okay, so that last part, what is the agent's rate? That's my unknown, the agent's rate. Okay, how do I know that's my unknown? Because that's what the question is asking me. Normally, you can look right at the question and it'll tell you what the unknown is, what you're looking for. Okay, so I read for comprehension. Okay, instead of reading it 15 times, I kind of underlined and circled the stuff that was going to be really important to helping me solve this problem. Then I selected the unknown. The unknown in this case is the agent's rate. Okay, so that's what I'm trying to figure out. Okay. From there, I took and I translated my English to math. Okay, the 10% was really easy because that's a number. The word of, you know, was a keyword, a buzzword, which means multiply. Okay, and then the word 15% was easy because that's also another number. Okay, and then once I did that, then I used math. Okay, now what kind of math did I have to use? Well, I had to use math related to multiplying percents. Okay, so when I multiply a percent, I can do it one of two ways. I can convert the percents to decimals and then multiply the two decimals together and follow the rules for multiplying decimals, or I can convert the percents to fractions and then multiply the two fractions together. Okay, and then at the end, I'm just going to verify my answer. Okay, and verifying your answer just basically sometimes verifying it means just looking at the answer and seeing if it makes common sense. If I'm getting if I'm getting 10%, then the agent better not be getting more than I'm getting, because if he's getting more than I'm getting, then that means I'm not getting anything. That means he's taking all my money plus they're giving him some on the top. So common sense for me means that whatever I come up with had better be less than 10% for him. Okay. And if he's getting 15%, well, it better be less than half of 10%. So I know his answer had better be less than 5%. So that's the way I just verify my work. Okay. Now from here, when I multiply the 0.15 by the 0.10, I can use a calculator for it, or I can just say 15 times 1. And then because I've got 4, when I look at this right here, I say, okay, well, let's see. I can say 15 times 10. And then because I've got 4 numbers behind the decimal in our problem, I'm going to have 4 numbers behind the decimal in my answer. Okay, so that's the way that'll work. Okay. Now, another way I could do this problem is, like I said, I can take the 15% and put it as 15 over 100. And then I can go 10 over 100, like that. And then I can kind of just cross cancel 1, cross cancel here and come up with 10. Okay, and I'm just saying 10 divided by 10 is 1, and 100 divided by 10 is 10. And then I can do the same thing with the 15 and 100. I can divide 15 by 5 and come up with 3. I can divide 100 by 5 and come up with 20, like that. Then 3 times 1 is going to be 3. And then 10 times 20 here will be 200. And then I can take 200 and divide it by, I can take 3 and divide it by 200. Okay, and of course, need to say I'm going to use my calculator to do that. And then that'll give me 0.015. Okay, so I can do it either way. I can convert the percents to decimals and multiply them, or I can convert the percents to fractions and multiply that way. You know, if I convert them to decimals, I got to use the math to multiply decimals. If I convert it to fractions, I've got to use the math, you know, to multiply fractions. Okay, so at the end of the day, that U part, you know, use math. Okay, I've got to know what math rules to use, you know, in order to finish up the problem. You know, once I finish with the translating the English to math. Okay, and then the last step is I simply move the decimal 2 places to the right, and then that's how I come up with the 1.5%. Okay, so here's another problem. Okay, and this problem is going to be done the same way. I'm going to use that RSTUV approach. Okay, I got a 50% discount. Okay, so that 50% discount, I'll just underline it, a discount of 50% on a certain item already discounted. Okay, so that's what I'm getting. That would give you a 50% discount on an item already. And then I've got an original discount of 50%. So really what the problem is saying is that I'm going to get 50% of 50%. Okay, so that's really what that's saying, because it's saying it right here, discount stores tend to imply that they would give a discount of 50%. So they're going to give a discount of 50% on a certain item already discounted. Okay, so that's going to be 50% of 50%. So that's what they're saying. I'm going to get 50% discount, okay, of 50%. Okay, now the unknown in this case is what is the actual discount now? Okay, so the actual discount is not the new discount and it's not the original discount. Okay, it is the total discount. It's the original plus the new discount. Okay, so my new discount, I'm just going to call that new. And then I had my original discount. My original discount was 50%, you know, because they told me that. And they said, well, you know, you were getting 50% off the top. So my original discount was 50%. Okay. And then my new discount was another 50% of the original discount of 50%. So 50% of 50%, you know, I can just multiply because the word of means to multiply. Or I could take 1/2, and sometimes it's better just to convert them to fractions. So 50% is 1/2 times 1/2, which is going to be 1/4. And 1/4, needless to say, is 25%. You know, you're getting a quarter of 4 quarters. So it's going to be 25%. Okay. Now another way of doing that is you could have took the 50% and made it zero point 0.5 and then multiply that by zero point 0.5 and then you would have came out with 0.25 that way. And then that would have equaled 25%. Okay. So whether you convert the percents to decimals or convert the percents to fractions, you're still gonna come with that 25%. Okay, now that 25% is the new discount. When I take the new discount plus the original discount, that's gonna give me my actual discount now. Okay, so that's gonna give me what I'm actually getting as far as a discount. So I'm gonna get new 25% plus the old discount of 50%. And then that's going to give me actual 75%. And so my actual discount is 75%. Okay. Now once again, what I'm doing is I'm looking at this problem, I'm reading it carefully, I'm taking the question that they're giving me and trying to figure out the unknown, exactly what it is that they want me to look for and find. Then I'm taking the English and I'm translating it to math. And part of that process is looking at it and saying, exactly, what does this English mean in terms of math? Okay, so I'm looking at it and I'm saying, well, this is a percent problem. They're talking about percents. So, that's the math that I'm going to translate it into percents. Okay. Then from there, I got to figure out what rules I use to solve percents. Okay, I can convert the percents to decimals. I can convert them to fractions. Then once I convert it to decimals or fractions, I've got to use the rules for decimals or fractions to solve the problem. Okay, yeah, that's right, Michelle. Zero point 0.5 and 0.50 are the same thing. Okay, and from there, let me clean this up. Back. And so we got 0.25, that's and then we've got the new discount of 25% plus the original discount of 50%. And when we add those together, that gives us 75% for actual. Okay, so here's a problem right here. I want to see if you guys can solve this one. It says a pair of boots costs $40 after a reduction of 20%. What is the pair's original price? Okay, let's see if you guys can solve this one. Okay, so let's see, Michelle and Linnell both have 48. Okay, any other input from everybody else? Okay, Joe has 48 as well. Okay, any other input? We got 3 responses. Okay, so let's take a look at it. Now, the strategy that I'm proposing, read, select, translate, use, and verify, that's not the only strategy out there, and that's not the only strategy that you have to use in order to solve this problem. Okay. One of the things that you could do is you can set up a table or draw a picture, okay, to help you better understand exactly what it is that you're trying to do. Okay. Sometimes you can set up a table, based upon this is the way these types of problems always work out. And then you can fill in the information into the table. Okay. So what I'm gonna do here is I'm gonna start off with the English. What I know about, discount problems. Just like if I was going in the store and buying some pants or buying a shirt or buying a hat, what do I know? Okay. This is what I know. I know I always start off with an original price. Okay. So I know that. And then I know if I'm lucky, I know I always get a discount. And then after the discount, I'm always left with a new price after the reduction. So I'm always left with a new price after the reduction. New price after discount. After discount. So that's the way it works. Okay. And this is a table that I can always use no matter what's given to me. Okay. So let's say they're not working with percents. It's not a percent problem. Let's say it's just pure money. There's a shirt that costs $45. And so I look at the shirt and I say, I really want this shirt. It's a really cool shirt. My wife likes it. I'm going to be getting a lot of kudos, from this shirt. So, but I don't want to pay no $45 for it, you know. So, the manager comes up to me and says, I'll give you $10 off. Okay. And then that means that my new price is going to be 35. It's going to be the 45 of the original minus the $10. And then that's going to equal my new price after the discount of 35. Okay. And so that's the way it always works. Okay. I go and I see a computer for like 2,000. They tell me they're going to give me 500 off of the price of the computer. You know, my new price is not going to be 1,500. It's going to be 2,000 minus 500 equals 1,500. Okay, so all these problems work out that way. Okay, now what I got to do is I got to figure out what they give me. No, $5 is not the same as 5%. Okay, because it's 5% is 5% of whatever you're talking about. Let's say if you were talking about let's say you're talking about $70. Well, 5% of $70 is going to be $3.50. And the way that works is that, like, say, for instance, if you got 70, you multiply it by 5%, which is going to be 0.05. Okay. And then, of course, 5 times 7 is 35, like that. And then the way it works is you say, well, okay, well, there is, well, let's see, it's going to be, that's going to be 350 because you got two numbers there. 5 times 70 is going to be 350. So 5 times 70 is going to be 350. And then because you got two numbers behind the decimal here, you're going to have two numbers behind the decimal in your answer. Okay, so 5% in this case is going to be $3.50 because it's 5% of whatever it is you're getting it off of. Okay, the way those problems work is you have a base times a rate. Okay, equals an amount. That's the way it works. Base times rate equals amount. Okay. Now the amount is the rate is always the percent. Okay. So the rate is always the percent. Okay. So and then the base is whatever you're multiplying the percent by. Okay. And so that's what's going to determine whether it's $5 that amount or not. All right. So we're going to take what we're being given here. Okay. Okay, so a pair of boots costs $40 after reduction. So they gave us the new price. The new price is 40 bucks. We're going to put that right in here. And the reduction is 20%. Okay, now how do we find that reduction of 20%? We multiply the base times the rate. Okay, in this case, the rate is 20%. So it's going to be 20% of the original price. So I'm going to call that original price, I'm going to call it, we'll call it P. And that's going to be multiplied by 20%. Okay, because that's how you find the discount amount. Okay, this amount right here is actually a discount amount. Okay, it's not a rate, it's an amount because it's a dollar amount that's got to be subtracted. And the amount comes from multiplying the base times the rate. So the base in this case is unknown. Okay, because we say, what was the pair's original price? Hence the question. We don't know what the original price was. Okay, but we do know the discount is the original price times 20%. That's the base times the rate. And whether we're dealing with a discount, whether we're dealing with taxes, okay, whether we're dealing with interest, it's always going to be the base times the rate equals the amount. So let's say, for instance, we wanted to know the interest. And then when we say interest, we're saying interest amount. That's what we mean by interest. So we're talking about the interest amount in terms of dollars. It's going to be the base times the rate equals the interest. Okay, now the way that works is, even though, because I'm kind of abbreviating this, we're talking about the base times the interest rate equals the interest amount. So the way that's going is the base times the interest rate equals the interest amount. Okay, or we can say the base times the discount rate equals the discount amount. Or we could say the base times the tax rate equals the tax amount. Okay. So that's the way it works. Even though we keep saying the word rate, it really means discount rate, tax rate, interest rate, okay, whatever the rate is. And then the amount is actually the discount amount, the tax amount, or the interest amount. So whatever the amount is, it actually has a name to it. Okay. So in this case, when we say, well, you get a reduction of 20%, you know, even though we're talking about the discount, finding the discount is a discount amount. And the way we find the discount amount is we take the base and we multiply the discount rate. They gave us the discount rate. They said the discount rate was 20%. The base we don't know, so we're going to call that P for, pair. Now, what is the original price? We don't know that either. So we're going to call that P as well. Okay, so there we go. Okay, so now P is also 1P. Okay, we got 1P there. Okay, so when we finish with this, we're going to have 1P times 20% of P, which means 20% times P, equals 40. And in this case, we can take 1P, and then we're going to take 20% and convert it to a decimal. So that's going to become 0.20P equals 40. Okay, now at this point, we're going to use math. Okay, we obviously converted the 20% to, 2/10. Okay, so that was math, converting the percents to a decimal. We had to use math to do that. And now we're going to use math to subtract the decimal. Okay, well, we can kind of take a shortcut and understand what we know about money. A dollar minus 20 cents is going to be 80 cents. P. Okay, now we know that when we're combining terms, if they're alike, we just add or subtract the numerical coefficients, the numbers in front, the 1 and the 0.2. We subtract those because the p's are the same. Okay. Now, we still got more math to do. We could say 0.8 times what will give us 40. Or what we could do is we can divide both sides by 0.8. Okay, and so we're going to divide both sides by 0.8 or 0.80. It doesn't matter. It'll still come out to be the same. And then that means P is going to equal, it should be 50. I'm going to go ahead and throw it in the calculator though. And so we're going to say 40 divided by 0.8 or 0.80, and then that's going to be 50. Okay, so that's going to be 50. Okay, so the original price was $50. Okay, now, according to the strategy that I use, we're still not finished because we need to verify that answer. Okay, so I'm saying it's going to be 50 bucks. Okay, so I'm going to go back and verify that answer just to make sure that it's right. Okay, so what I'm going to do, okay, so what I'm going to do is I'm going to take, I'm going to say $50 times 20%, which is going to be 10 bucks. Okay, now obviously that's my discount, $10, because I got my base of 50 multiplied by my discount rate of 20 is going to give me my discount amount of 10. Okay, so $10 is my discount amount. So I'm going to take my original price of 50 which is my base. Got to minus my $10 from it, which is my discount amount. And then that's going to give me my new price of 40. Okay, so I verified it. Okay. Um, but with these kind of problems, what we're doing is we're starting out by doing a lot of critical reading and reading carefully for comprehension. Okay. Looking for keywords and concepts to let us know, what kind of math tools we can use. Okay. We got to always translate the English to math. Certain words like of means to multiply. Okay. Sometimes when we're looking at a problem, we see words like is. We got to know that we can use equations. Okay. We're going to always, in this case, we use the table. Okay. Because every discount problem works the same way. You got the beginning price minus the discount gives you the new price. Okay. And so that's the way we end up working out the problem. Well, it's incorrect, Michelle, because if you got 20% of 40, that's 8. Okay, but $48 is not going to be your original price, because if you took 48 and multiplied it by 20%, let's say we took 48 bucks and we took 20% away from that. So we would have to multiply it by 20%. So we would take 48 and then we multiply that by 20%. 48 times 0.20. That's going to give us like $9.60 off. So that's what we're getting off, $9.60. All right, well, if you got 48 bucks and you take away $9.60, your new price, okay, 48 minus $9.60, your new price is going to be $38.40. So that won't work. Okay. Yep, Joe, you're right. You can actually do that. Okay, you can take, because that's kind of like an off concept. You can take 100%, okay, minus the 20% and come up with 80 and do it that way as well. Okay, so yeah, you could do it that way as well and still come up with 50. There are like 3 or 4 different ways you can do this problem. Okay, that one way that I showed you by setting up the table, by all means, is not the only way to do this problem. Okay, and remember when we first started, and I said the strategy that I'm giving you guys, that RSTUV strategy, is not the only strategy to use either. Okay, so there are different strategies, and then there are also different ways of doing the problem. That's why when we did that first problem, we started off with decimals and then we turned around and used fractions, to show you that there's more than one way of doing the problem. Okay, no matter what way you do the problem, you just want to make sure you're using the math rules correctly. Okay, because that was in that RSTUV strategy, is making sure you use the right math rules and using the math rules the right way. But there's probably 3 or 4 different ways you can do this problem. Okay, so we clean this up, and then we'll look and see how they planned it out. They took the $40, 100% minus 20 gives us 80%, and then they divided both sides by 80%, and then that gives us 50. Okay. Okay, so here's another problem. This is going to be a markup based on cost. Now, markup means the price is going to increase. We've seen this type of problem before. Okay, we actually seen this type of problem when we were working with the increases. Okay, where we had like um, the assignment one, and we said it increased by 24%, then it decreased by one third. Okay, so this is that same type of concept, increasing by 43%. Okay, so let's see if we can figure out what the dollar markup is. Okay, and then we can figure out what the selling price is. Okay, now let me say this about the dollar markup. Remember that base uh, times rate equals amount, equals amount. Okay, remember that concept? Because here we've got percent, which is the rate, and then we've got dollar here, okay, which is amount. Okay, so percent means rate, and amount in this case is dollar. So let's use that base times rate equals amount concept to solve for the dollar markup and the sales price here. So what do you guys think the dollar markup is going to be? And what do you guys think the sales price is going to be? And feel free to take your time. Don't rush. There's a cliche in math: haste makes waste, and haste means to speed, and waste means to be wasteful. Okay, so let's see. We got a markup of 35.26 by Joe, and then we got a selling price of 117.26. Okay, so Noreen says she's got the same thing as Joe. Okay, cost times percent. Let's see. Lionel seems to have the same thing as well. Does have the same thing as well. Okay, Michelle has the same thing, so we have a consensus opinion here. Okay, now that formula base times rate equals amount. Okay, in this case, the cost is the base. Okay, the percent is always going to be the rate. Okay, and in this case, dollars are going to be the amount because that's what we're talking about. We're talking about dollars. Now we can have other amounts besides dollars, but in this case, dollars just happens to be the amount. Okay, this formula always holds, and it's a good formula to remember. Base times rate equals amount. If someone's talking about the amount of interest, the base will be the principal, the percent will be the rate, and then the base times the rate, or should we say the principal times the percent, will give us the interest amount. Okay, so that's gonna hold. So you guys did an excellent job with that part of it. Okay, and then Noreen's explained to us how we come up with the selling price. We're gonna take the cost and add the markup amount to it. Okay, because we know we got a percent markup and then we got a dollar markup. The dollar markup is the markup amount. Okay, and the percent markup is the markup rate. Okay, so you guys did an excellent job with this problem. Okay, and there we go with the 35.26, and we added it to the $82 to come up with the 117.26. So excellent job. Okay, hold on to that formula: base times rate equals amount. No need to reinvent the wheel. Okay, if it's already been invented, just enjoy it and use it as much as you can. All right, so here we got another type of problem. We've got a markdown problem. Okay, so we got to see if we can solve this problem. And we're going to use the same concept here. Okay, so what are you guys coming for? A dollar markdown and then a percent markdown. Okay, let's see. Michelle's giving us a markdown of 25.20. Is that a dollar markdown or is that a percent markdown, Michelle? Okay, a dollar. And Noreen was saying that she would subtract the original from the reduced price. Okay, so if you did that, Noreen, what would you come up with? Okay. Okay, so oh, you're asking? Okay. Well, Linnell came up with $2. Okay, okay. So now you're saying okay, so you came up with $2. Okay, okay. For the markdown. Okay. Um, Michelle's wanting to know how you guys did that. Okay, so Noreen says she took the $70 and she minus the 68, and that's how she came up with the markdown amount. So she went 70 minus 68 because the price went from 70 to $68, so it went down $2. Okay, and the percent. Okay, now the percent's going to be the same way. Okay, because we now know what the markdown is. The markdown is now 2. Okay, so we still got that same formula. The base times the rate equals the amount. Okay, so the amount was $2, right? Okay, so we'll put it down here. Base times rate equals amount. we said the amount for the markdown was $2. Let's move this out of the way. Okay, so we said it's $2. Okay, because we said we're gonna hold on to this formula. No need in reinventing the wheel. Okay, so we know what our base is. Our base is the original price. Okay, our amount is the dollar amount. And the markdown percent is the rate. Okay, because percent means rate. Okay, so, and of course we can see that we've got markdown here, we got markdown here. Okay, the only difference is this is markdown percent, that's markdown dollar. Okay, so the dollar makes the amount. Okay, so the base was $70, and then that's going to be multiplied by the rate, which we don't know what the rate is. So we're going to call that R. But we do know what the dollar amount is. That's going to be 2, because we figured that out, right? 70 minus 68 gives us the amount. Okay, much like if we were looking at a discount. Okay. Now from here, we've got to solve this like an equation. Okay. So what we've got is we've got 70R equals 2. So we got to get rid of 70 from both sides. And then R is going to equal 2 divided by 70, 0.02857,143. And it says round to the nearest hundredth. Okay, round to the nearest 100%. Okay, so first thing we got to do is obviously we got to convert it to a percent. So we're going to move it 2 places. 2.857,143. Okay, and so the nearest hundredth is going to be where the 5 is. So then that means that that's going to get rounded to 2.86%. Okay, so that's going to get rounded to 2.86% because the hundredth place, good place to always remember the hundredth place is just think of pennies. So whatever number's in the dollar amount for pennies, that's going to be your hundredth place value. Okay, so we got the $2, divided it by 70, and then we came up with a 2.86%. Okay, always remember that formula: base times rate equals amount. Okay, that formula is always the key. Okay, sometimes with the formula we have to work it backwards because we have to solve, for one of the other variables. Sometimes we have to solve for the base. Sometimes we don't know what the base is. Sometimes we have to solve for the amount because we don't know what the amount is. And then sometimes we have to solve for the rate because we don't know what the rate is. But at the end of the day, all of those problems work out the same. The base times the rate equals the amount. Okay, it's the same wheel, okay, that we're using. We don't have to reinvent that wheel. We just keep using it. All right, here's a problem for us. Let's see if we can solve this one. This is a business problem. Okay, and not only is this a business problem, but this is also a grade book problem too. 'Cause we see this when we're working with our grades. Okay, Michelle, you got your hand up. Did you got a question for me? Okay, okay, so okay, okay, so we got answers coming in for the average. It's going to be 43.75. Okay, so we got two responses already on that. $43.75. Okay, Michelle also has an answer 43.75. Okay, and Michelle also provided us with the steps for how we actually calculate that average. Okay, so we want to thank Michelle for that. Okay, so we've got an answer 43.75 on this one. It looks like you guys have done a pretty good job on it. Okay, I just want to say two things about an average. Okay, an average is a very important concept, math concept. It comes from statistics. Okay, an average allows us to do two things. One, the first thing an average does, it allows us to compare, you know, ourselves with everybody else. So it lets us know how good we're doing, whether we're doing good or bad. Okay. So, for instance, I'm not a tall guy, I'm short. Now, how do I know I'm short? Because I can compare my height to the height of an average male. Okay, an average male in the United States is about 5'10. You know, I'm not 5'10, I'm 5'6. So, based upon, my height, I know that, I'm not average. I know I'm below average. I know I'm short based upon the average height. Okay, so the first thing an average does for us is it allows us to compare, okay, ourselves, or allow us to compare something as to, how well it's doing, whether it's doing good or whether it's doing bad. Okay. Another thing an average does for us, it allows us to see how challenging something is. Okay. Well, if let's say for instance, you you're taking a test and the average score on a test is a B. Well, then, that test is, a pretty easy test because, most people are making a B on it. Versus if you got a test and the average score is an F. Okay, well, that's a hard test because most people fail that test. So averages allow us to do two things. It allows us to compare individuals, either ourselves or others, okay, to how well we're doing in reference to everybody else, whether we're doing good, bad, or whether we're doing okay. And then an average also allows us to determine how difficult something is. Okay, so let's say, for instance, in the United States, The mortality rate, the average age of a male uh, at death is around 74, 75. So we know once we get above 74, 75, it's going to be hard to stay alive. Okay. So that's what averages do for you. It allows you to compare yourself or something, you know, to everything else. It allows us to know if something's good, bad, or average. So a guy that's 85 years old, then, he's living real good. I mean, he did a real good job, with the longevity of his life, because he outlived the average person by so many years. Okay, so those are the two things about averages. Okay, and one of the reasons why we use averages so much. Okay, your blood pressure is an average. So is your sugar level. It's based upon an average. Okay, white blood cell count is based upon an average. Okay, even your finances or your credit score is based upon an average. Okay, so averages are good tools to use. Okay, you guys obviously got it down pat how you figure out an average. You add up everything and then you divide it by the amount of items in the group. Okay, and so we can see right there, you guys did an excellent job. Okay, but just because it's fairly easy to come up with the answer. Okay, don't discard this as a math tool as far as being a very effective tool. Okay, averages are very powerful tools, and they allow us to make very well informed decisions. All right, here we go. Best buys. Okay, so we've got two buys here. We've got a can of mushrooms for 12 ounces, and then we got another can of mushrooms for 10 ounces. Okay, using math, which one of these uh, cans is going to be the best buy? I think I kind of helped you guys out a little bit with that. Okay, so which one is going to be the better buy? The 12-ounce can or the 10-ounce can? Okay, Michelle, that's an honest answer. Thank you for sharing it with us. Okay, Linnell. Okay, so Joe's saying the 10-ounce can. Okay, Joe, why are you saying the 10-ounce can? Okay, so you divided the prices. So you used division to compare the two. Okay, excellent. Okay, any other input? Okay, if no other input, Joe is correct. Okay, we definitely want to use division to compare the two different items. Okay, if you notice when we were looking at the averages, we used division to find the average so that we can compare everything to an average. So we're going to do the same thing here. Now, what this is going to do is it's going to give us a unit rate. Okay, and a unit rate is very important. We just got finished dealing with weights when we talked about base times rate equals amount. Okay, a unit rate is a rate by which we can compare things that are different. A rate is something that is a common unit that we can use to compare two things and make them more similar or more alike. So Joe was correct. We're definitely going to use division in this case. We use division a lot to compare things. Okay, so let's look and see how this unfolds. Okay, we converted the dollars to cents, and that's just because it was easier to divide by once we converted the dollars to cents. So we got 199 cents, and then we got 179 cents. Then we divide the 199 cents by 12, and that gives us 17 cents per ounce. So that's our rate. Our unit rate is 17 cents per ounce. So if we had 50 ounces, we would multiply 50 by 17 cents to figure out what our total price is. For the 179 cent, which was obviously the dollar and 79 cent, we divided that by 10, and that gave us a unit rate of 18 cents per ounce. Okay, so that gave us a unit rate of 18% per ounce. So we used division to figure out which rate is cheaper. The 17 cent per ounce rate is cheaper. Therefore, the 12 ounces is going to be the better buy. Okay, because you're getting it at a cheaper rate. Okay, you're paying 17 cent per ounce. Okay, versus 18 cent per ounce. Right, right. That could be the case, Michelle. That happens a lot. Okay, so here we got another one. We've got 3 ounces of salami, the same weight. We want to know if that's the same rate as a quarter pound of salami. Now, I'm not going to ask you guys to do this one because in order to do this one, you're going to have a conversion rate. Okay, now a conversion rate is a rate that we use to convert two things that are different to the same unit of measurement. Okay, for instance, let's say, for instance, if we had, let's say we had uh, 38 feet, and we had, say, 15 yards, and we want to compare these things. Okay, well, you can't compare feet to yards. Okay, and the reason why you can't, because that comes back to a universal truth about math. We can't compare apples and oranges. Okay, ever heard that saying, you can't add apples and oranges? Okay, but that's a universal truth in math. You can't compare things that are not alike. Okay, that's why if you've got like three x's and five y's, they say you can't compare them, you can't add them because they're not alike. Well, 38 feet and 15 yards are not alike. So what we're going to look for is a conversion rate, something that we can use to convert one unit of measurement to the other unit of measurement. Now for us, with feet and yards, we know that 3 feet is equal to 1 yard. Okay. So in this case, our conversion rate is going to be 3. Okay, it's going to be 3. So either we're going to multiply or divide by 3. So if we wanted to convert the feet to yards, we would divide by 3. We would say 38 divided by 3, and then that's going to give us 12 yards and 2 feet. Okay. And so at that point, we can see that 12 yards and 2 feet is not bigger than 15 yards. So, now, let's say, for instance, we didn't want to convert the feet to yards. Let's say instead we wanted to take the yards and convert them to feet. Okay. Instead of dividing by 3, we're going to now multiply by 3. So in this case, we're going to multiply. But in either case, we're going to be working with 3 because 3 is the conversion rate, because 3 feet equal 1 yard. And it's coming straight from the conversion here. That's where that 3 is coming from. So we're going to say 3 times 15 is 45 feet. And at that point, we can see that 45 feet is clearly bigger than 38 feet. Okay, so that's what conversion rates are all about. Okay, we take a conversion rate and find a way to convert two different units of measurement to the same unit of measurement. And then we compare the two things. Like if we were looking at two different units of measurement in times of time. Okay, and a unit of measurement is how we measure one unit of something. We can measure distance, we can measure quantity, okay, we can measure time itself. Okay, 1 minute is a unit of measurement, 1 hour is a unit of measurement, 1 second is a unit of measurement, 1 week is a unit of measurement, 1 second is a unit of measurement. So we're talking about units of measurement here. Now, when we're looking at these units of measurement, it's important that when we're comparing things that, they have the same unit of measurement. You can't compare apples to oranges. That's a universal truth, in math. Okay, so what we're going to do is we're going to look at this. And obviously, we're going to need conversion rates. Now, if let's say, for instance, I got a question for you guys. If we don't know what the conversion rate is, where can we go to find the conversion rate? How can we find it? Google, excellent. Google. We can go to Google. Okay, Google would tell us what the conversion rate is. You can just ask, how many pounds are in an ounce? And Google will tell you. Then we can take whatever that conversion rate is. In this case, that conversion rate is going to be 16. Okay, we can see it right there, 16 ounces in a pound. Okay, so in order to work this problem, we're going to either multiply or divide by 16. Okay, so if we wanted to convert pounds to ounces, we would multiply by 16. If we wanted to convert ounces to pounds, we would divide by 16. Now, what determines whether you divide or multiply depends on which one is larger. Okay, and you can look at the conversion rate and see that 16 is clearly larger than 1. Okay, so if you're trying to go from 3 ounces to pounds, we can see that you're going from a larger to a smaller. And how do we know that? Because you're going from 16 to 1. Okay, and 16 is clearly larger than 1. So in order to go from a larger to a smaller, when you go from large to small, division makes things smaller. Okay, so 3 divided by 16 is what you'll do to get small. Just like if you had 16 ounces, 16 divided by 16 will give you 1 pound. Okay. Now, when we're going back the other way, obviously when we're going from, a quarter of a pound, and we're going to ounces, okay, we can see that we're going bigger because we go from 1 to 16. So we're going to be multiplying by 16. Okay. But in any event, our conversion rate is going to be 16. Okay. You won't, the conversion rate will never be the 1. It will always be the other number. So the conversion rate is going to be 16 in this case. So either we're going to divide by 16 or multiply by 16 in this case. Okay. And so we'll go 3 divided by 16. And then if we're going to convert the pounds to ounces, we'll go a quarter of a pound, 0.25 multiplied by 16. Let me clean this up. Okay, and so when we divide by 16, we can see that 3 divided by 16 is going to give us 0.19 1900th of a pound. Okay, so we can get 1900th of a pound. And if we went the other way, because there's always 2 ways we can do it, we're going to come up with 16 times 0.25, and that'll give us 4 ounces. Okay, so we can see that 1900th of a pound and 2500th of a pound are not the same thing. And we can also see that 3 ounces and 4 ounces are not the same thing. Okay, so no matter how we do it, they're not the same. Okay, now another place we'll see math is with personal finances. Okay, here we've got a checkbook, and we can just see what happens when you overdraw money. In this case, Karen had $150, and she takes out $100 twice. Not a great idea, but she did it. And of course, we're not going to count for, in this case, we're not going to count for the overdraft fee. And so we'll see 150 minus 100 minus 100. And we can see, in this case, she's going to have a negative 50. Another thing that we'll do is we'll look at a checkbook. In this case, we use math to figure out our checkbook. Now, I like to use programs like Quicken, okay, because they have an automated checkbook inside of them. And so it's easier to do the math with those. Okay, so we have Amy in this case deposited $1,231.40. She wrote a check for 176. She wrote check number 176 for $252.24. I had a cash deposit of $1,472.86 on May 21st. So we're going to fill in Amy's checkbook. And this is the way the transactions are going to look. Okay, now you're going to see something similar to this in Alex. Make sure that when you're doing the Alex checkbook that you're putting in the right check numbers, that you're putting in the right dates, okay, and that you're entering in the right amounts under the right columns for payments and deposits. And then the last part you really want to do is make sure that you're doing your balances correctly. Because if you're missing any of this stuff, especially your dates, Alex will mark the whole thing wrong. And then it's kind of frustrating when you're looking at that and you're trying to figure out exactly why it's not working out. Okay, and so we can see what happens as she makes a deposit. It's going to increase her balance. As she writes checks, it's going to decrease the balance. She seems to be getting paid a lot because that's 3 deposits in 1 month. Balance definitely gets increased. All right, we're going to skip that video there. It's a kind of a humorous video. I'm trying to see if I can copy it. Let me see if I can. Let me see if I can shut it down. I'll send it to you guys. It's funny. It's a Saturday Night Live video. What they're kind of doing is just making humor of the way people think about money. Okay, on your free time, you can feel free to look at it. Okay, another concept that we run across in business is depreciation. Okay, and so the definition of depreciation is how much the value of an item is reduced over time. Okay, so that is the concept of depreciation. Now, what we start off with is we start off with a salvage or a residual value. Okay, and so the salvage value is at the end of the day, if we had to sell it for junk, how much would we get? That's the salvage value. Everything normally has some kind of salvage value to it, unless it's a perishable item like food. Now, the estimated useful life is how long something lasts. Now, typically in the world, when we talk about how long something will last, okay, the IRS has a booklet that tells us how long cars last, how long, a building will last, how long, transportation will last. So, that's the best way of looking at it. You can look at an IRS manual, it'll tell you, you buy a computer, this is how long it's going to last. This is the estimated useful life. Okay, so, and things like technology don't have a long life. It's not because, they tear up real fast, but it's because we come out with new things that make it obsolete. Okay, so, you can, you can say purchase a computer and in 3 years they got something that's so much better and there's so many different software programs that that computer is now obsolete. So that's why computers normally have about a useful life of 3 years. Oh, what about now? Can you hear me? Can you guys hear me? Okay, okay. For some reason, the mute button got pressed. Don't know how it did it, but it happened. Okay, so let's look at the annual depreciation again. Okay, so here's the formula. The cost minus the junk value divide the useful life. So the cost is 25,000. The junk value is 1,200. And the junk value is whatever it costs after you sell it for junk. What's left? And then we're going to divide that by 5. And so that's going to give us our annual depreciation, which is going to still, the annual depreciation is going to be the same thing every year. So in this case, it's going to continue to be 4,760 every year. Now, if we want to know what the accumulated depreciation is for the second year, we'll take that 4,760 and multiply it by 2, okay, because it's the second year. If we wanted to know what the accumulated depreciation is going to be in year 4, we would take that 4,760 and multiply it by 4. Okay, and then that would give us what our accumulated depreciation is. And so in year 2, that's going to give us 9,520. Now, if we wanted to know what our book value was, we're going to take the 25,000, which is our original cost, and then we're going to subtract how much depreciation has accumulated after 2 years, which is going to be 9,520, and then that's going to tell us what it's worth. That's going to tell us what our book value is. The book value is always going to be the cost minus the accumulated depreciation. The best way to remember this concept is always think about a car. Okay, the car is always going to drop around the same price each year. And then the book value is always going to be less than whatever you paid for the car. Okay, the cost is what you paid for it. The accumulated depreciation is how much depreciation the car has dropped by or reduced by. The price of the car has moved down by each year. Then when you subtract the two, that's going to always give you the book value. Okay, so now the book value is 15,480. Now what that book value is that book value is letting us know that if we want to buy or sell this vehicle, that we can only sell it for 15,480. Okay, so here we've got another situation. We got depreciation. We got a truck was purchased for 30,000. Okay, it has salvage of 1,000 and an estimated useful life of 3 years. Okay, so I'm gonna let you guys see if you can figure out depreciation on this one. What do you guys think the annual depreciation is gonna be on this truck? Now remember, the annual depreciation is what it is every year. How much is it dropping each year? So how much do you guys think is dropping each year in price?
Can you hear me? You didn't ask him. You still understand.
Okay, so Lionel has $9,667. Lionel has $9,667 as far as the depreciation. Okay, how about everybody else? What are you guys coming up with? Okay, not sure. That's an honest answer, Michelle. Okay, so let's take the information we have. Okay, so Lionel's showing us how to do it. Okay, we're gonna start off with 30,000, and then we're gonna subtract 1,000. Does anybody know why we took the 1,000 out? Does anybody know why we took the 1,000 out? Why salvage value? That's correct, Joe. Salvage value. The salvage value is not going to reduce or go down beyond the salvage value. So it's not going to. So the salvage value, we're going to always have that value. So it's not going to reduce beyond that value. So we can take that out. So that means there's going to be $29,000, and it's going to depreciate $29,000 over the 3 years. So we're going to spread out that 29,000 over the 3 years. Okay, so Lionel did a good job with this. Okay, now 29, so $9,667 is for a year. Okay, that's for 1 year. Okay, but this question right here is going to ask us to figure it out for a month. So, how much depreciation is that going to be for a month? Okay, so 3 years is for 3 years. For 1 year, it will be 9,667. But how much is it going to be for a month? That's correct, Joe. We can divide that by 12. Okay, so we can divide that by 12. Okay, now if we knew that we were going to, if we knew that we were going to depreciate it by the month, we could have started out by dividing the whole thing by 36. But dividing it by 3 and then dividing it by 12 will give us the same answer. And so that's going to be $805.55. And let's see. So here's our formula. So in this case, the estimated useful life is going to be 36 months. And when we finish with the math, that's going to be $806. Now, the $806 is because we're rounding it to the nearest dollar. So that $805.55 that Lionel came up with is the same as the $806. We just rounded it to the nearest dollar. Okay. So we wanted to know how much it's going to be after 1 year. Okay, we can take the cost and minus the depreciation, which is going to be the 9,672, and then that's going to give us 20,328. Okay, we've got about 5 minutes left, so we're going to finish finish this last 5 minutes working on a concept of taxes, and then we're going to call it a day. We'll leave 5 minutes for questions. It says in 2003, how much will a single taxpayer with taxable income of 30,000 pay? Okay, so here we go. We've got 2003, 30,000. Okay, now $30,000 made is in between these two amounts here. Try to use my pen, didn't work. 30,000 is between these two amounts. Okay, so with that being said, our taxes is going to be based on this right here number. Okay. All right, so for the 30,000, what's going to happen is the anything from 28,000 to 400 is going to be in this amount here. It's going to be right here. Let me see if I can get this amount pushed in right here. So that's going to be the taxes for the 28,400. Okay, 3,960. Anything above that 28,400 is going to be taxed at 27%. So anything above that is going to be taxed at 27%. Okay, so we've got 30,000 minus 20,800. That's going to be 1,600. That's going to be taxed at 27%. Okay, and so what we'll do is we'll take that 27% times 1,600, and we'll add that to the 3,960. Okay, and then that'll give us $4,392 in taxes. Okay, but that's how we use the IRS tax schedule to calculate our taxes. And of course, there's math involved in it with, adding and multiplying percents. Okay, and so logistically speaking, that's how we do it. Now, most people just use TurboTax to get that done, and then that way the system will calculate your taxes for you. But one thing when you're using technology, if you don't know the math behind it, you're not going to be able to do any planning. Okay, so the math behind it helps you plan. Okay, so well, if I go over a certain amount, okay, I gotta invest a certain amount of dollars in my IRA, in my 401k, or I gotta use a what do they call it? A pre-tax shelter, like health insurance or some kind of medical write-off or charitable contributions. Okay. All right. So that's going to wrap up our go-to training today as far as the information that, I have available to present to you because we're closing out at 4 and it's 3:55. I'm going to leave these last 5 minutes for questions and answers. So if you have any questions for me, this is a good time to ask. Okay, Lionel, you have a question? Okay, what's your statement? Yes, you can, Michelle. Sure. Okay, you're unmuted. Okay, Michelle, you have to be unmuted. You're unmuted.
Oh, Professor,
Yes.
Lionel was talking to you, not me. That's Lionel talking to you.
Okay. Okay. No problem. What's your question? Oh, oh, you said- Janelle? Yes. Yes, you're unmuted. Oh, it's Linnell. Okay. All right. Thank you. All right. Thank you for correcting me. Yeah, I was thinking of Linnell guys. All right. So it's Linnell. Yeah, but we're probably thinking about Lionel from the Jeffersons. Yeah, yeah, that's what I was thinking. So, but Linnell is nice to know. Okay, good deal. Now I know. I'm sorry about that. Okay.
Mr. Clark,
Yes.
I was wanting to know when we're doing graphing lines, giving the let's say graphing the line, giving its equation in standard form. It's okay for me to solve the equation when there's like two variables, or it may say like 2x minus 5y equals 15. But when there are three, and it may have like 2x minus 5y plus 8 minus 0, that throws me off. Is there, can I like look at something? Do you already have a video like going over that again where it may have more components to the equation?
Um, hold on a second. This is for me. Let's see. Let me push this down. Push that out. Push that out. Give me a problem again that you're talking about. Give me a similar problem.
Okay. Okay, let me find. Um, so for example, this one says, here it is. I'm all over the place. 2x minus 5y plus 8 equals 0.
So I say equals 0.
Yes.
Okay. What you want to do with this problem is you want to get that 8 to the other side. Okay. So,
Okay.
so the way you'll do that is you'll just if that's an addition of 8, you'll subtract 8 from both sides
Mhm.
like that. Let me put that in here so you can see what I'm doing.
Okay.
Okay, like that. And then what that's gonna do for you is that's gonna leave you with this right here. Let me make it color back. Okay, so that's gonna leave you with that. 2x minus 5y equals negative 8.
Mhm.
Okay, so now it looks a whole lot like
Oh, okay.
the other problems that you're working with.
Okay. I think I don't know where I worked it out at, but it was looking similar to this, but I was ending up with a fraction. It wasn't solving as a whole number, I think, but I don't
Yeah,
see where I was working it out now.
yeah, it depends on what numbers you throw in there. Okay, like
Mhm.
sometimes people try to throw the zeros in there. But see, you can use the y-intercept. Like the y-intercept here uh, will I'm sorry, the x-intercept will work. Okay, so the x-intercept will work for you like that.
Mhm.
And then of course your numbers are going to be negative for the order pair. It's going to be -4 and 0. So that'll work for that one. But when you get ready to your next numbers you put in, you got to be very careful with them like because they will end up dropping. It's like if you try to put a zero in for x and then solve for y, it's not going to give you a whole number.
Right.
So what
Mhm.
I would do is I would say, okay, I'm gonna put I'm gonna just put a 10 in here. I'll put a 5 in here for now, and then I'll probably end up changing it 5 here, and then I'm gonna put a 2. I'm gonna put a 2 here like that. All right, so that's gonna give me 10. Now I know I got to get to negative 18, and so 10 minus 10 is 0. So to get to
Mhm.
negative 18, I've got to somehow make this uh say something like maybe 1. And now I've got, when I do the math on this, it's going to be 2 times 1 is 2, minus 10 will give me negative 8.
Right.
Okay, so my second order pair in this case is going to be uh, 1 and 2.
And so basically, you're choosing your own numbers.
Yeah, yeah, you can choose any numbers you want as long as they allow the left side and the right side to equal each other. And
Okay.
anything that you put on that graph will be your answer and will fall right on the graph somewhere. It's going to fall somewhere on the graph. So it doesn't have to be like, it doesn't have to be like, you don't have to use like 0, 1, and 2.
Mhm.
Use any numbers you want to. Most
Okay.
people try to keep their numbers small so that
Okay.
you don't have a really, really big graph. And so that your multiplication and your addition is really, really easy inside your head.
Okay. Okay, that makes sense. That makes sense. And then one more thing, real quick, is when I'm solving the equation and I run into a negative, I'm seeing that the signs are changing when I'm looking at the explanation, and I'm trying to find out why are the signs changing.
Yeah,
So, for example,
yeah,
it may say 2x minus 5y equals 15. And then as I work it out and I'm running into negatives, it's showing me to change those negatives into a positive.
yeah,
I'm trying not to take up a whole lot of your time. I'm sorry.
because of the subtraction, like like
Mhm.
like with this one right here, I mean, you can put a 0 in for the x, but if you put in, say, for instance, what some people make the mistake of doing, if they'll put a 3 in like that, well, 5 times 3 here is going to give you a negative 15. So that's not going to
Okay.
work. See, if you finish with the math here, that's going to give you 0 minus 15, which is not going to equal 15. That's going to, because 0 minus 15 is going to be negative 15.
Negative. Right.
So
Mhm.
that's not going to work. So anytime you're multiplying with a subtraction sign in front, then you got to treat that like a negative. So that's going to be a negative
Okay.
5, and then that would have to be a negative 3. And then at that point, what you got is you got 0 minus negative 15.
Okay.
And 0 minus negative 15 becomes 0 plus 15,
15. Oh,
which
I see.
equals,
Okay.
which equals 15.
Mhm. I see. Okay.
I
That
always,
makes sense.
I always treat the subtraction signs like they're negative signs. And then that way,
Okay.
when you multiply, you know that you're going to need double negatives to come up with a positive.
Okay. Okay. That makes sense. That makes sense. And lastly, if when on your page, can I go back to like review this particular subject on your like your YouTube or any of your previous go-to meetings?
Yeah, you can. I mean, like this right here, the stuff that I just put on here for you,
Uh-huh.
I have not stopped the recording. So it'll
Okay.
show up at the end of the recording.
Oh, okay. Perfect. Okay. Yes, sir. Thank you. You've answered my question though. I'll review this, but that's pretty much the gist of it.
All right, good deal.
Okay, thank you so much.
All right, you have a good night.
You too. Bye bye.
Okay, bye.
I am going to stop. I need to learn. Hey.